Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about enum flags. This is a special thing you can add to your enums to make them work like bits, which enables you to do bitwise operations on them. Okay, so in the beginner section, we already covered enums. So here's a basic enum that represents various abilities. Now let's say we want to use this to define what abilities our player has. We can easily define a field of this type, and we can say, for example, that the player can jump. Okay, that's it, pretty simple. But now let's say we want the player to be able to both jump and shoot. Like this, we can't actually do it. We can't do something like ability jump plus shoot. That doesn't really work. We can't add it onto here. We can only override it. So inside of this one, we can really only store a single ability. But that's exactly where enum flags come in. First of all, we just add the flags attribute. So up here, an attribute for flags. And this one, by the way, exists inside of system. So we add that attribute, and then over here, we define numeric values to all of these enum values. Meaning we use equals and then some kind of number. Now specifically for this use case, we want to use powers of 2. That's very important. So for example, for none, let's assign it to 0. For jump, let's assign it to 1. For sprint, let's say 2. Shoot, 4. And fly, let's assign it to 8. Now in the previous lecture on bitwise operators, we already covered binary. That's exactly what we're doing here. In fact, like we mentioned on the previous lecture, over here, instead of using numbers, which can seem a little bit confusing, instead of that, we can just use bit shifting. So you can do 1 bit shifted by 0, and that makes a 1. Then 1 bit shifted by 1, bit shifted by 2, and so on. Yep, just like this. So we mark that as a flag, and we define the values as power of 2. Now with this, we can actually solve our original problem. So we want the player to be able to both jump and shoot. And with this, we can now combine our enum values. So we can make a jump or, and this is the bitwise or, so again, just one pipe, or ability.shoot. And if that's it, if we now do a log on this, so let's do a right line on the player abilities. If there it is, the player can jump and shoot. So here we have the player abilities field. That's just one field, just a single field, but it is actually storing two separate pieces of data. It stores that the player can jump and can shoot. So here we define it. Now let's say that we want to check if the player can jump. If so, we can just go inside the player abilities and we can use the hasFlag function. So let's say if the player can jump, let's do a log on this, like this, let's test. And if there it is indeed true, the player can jump. Or alternatively, since over here really we are just working with bits, because this we can really just use some basic binary math. So if we want to check if the player can jump, if so, we can just take our jump ability, so just like this. And then we can do a bitwise AND operation, doing an AND with our player abilities. And basically the output of the bitwise AND, this one is going to be 1 when only both these are 1, which in this case means it's only going to be jump. So we can just compare if this one equals ability.jump. Let's put this one inside parentheses. So let's see if the player can jump. And if that is true, the player can indeed jump. So enum flags are really super useful for combining multiple options in a single enum field. It is just like the layer mask that we saw in the previous lecture. How Unity has this type, which lets you select multiple layers. So here in the editor, we see this field and we can easily select as many layers or as few as we want. And here Unity also already supports the flags enums. So if we do this and we expose a field of our flag enum, then up here in the editor, we do indeed get a drop-down menu where we can select as many or as few things as we want. Now, another thing we can do with enums, not necessarily related to flags, is we can actually define the underlying type we want this enum to use. By default, this one is going to use an int, meaning it is actually going to use 32 bits. But if you want to limit memory as much as possible, if so, we can actually define what type we want this to use. And you do that by adding a little colon, and then define this one as a byte. So yep, now storing a field of this type is just going to occupy a single byte. Now naturally, byte means 8 bits. So if you want to store it as a byte, you are going to be limited. So yep, like this, if we define more than 8 possible values, yep, here we do have an error. Basically, a byte can only store 8 bits, so we cannot add 9 possible values here. If you want more of those, then you can use a short or just default int. Then yet another interesting thing you can do here is you can also define some combinations. So you can define one for shoot and fly, and it can do equals shoot or fly. And yep, again, this one is going to do a bitwise OR operation, and it's going to combine both the shoot and the fly tag, and both them inside of this one. Okay, great. By the way, I should also mention that technically the flags attribute, this one is not really required for this. You just need to assign the binary values and all of this works. But if we don't assign the flags, if we don't do that, let's see what this one is going to log. And if there you go, that one just logs the number 5. Whereas if we have the flags attribute, yep, that one logs the proper readable thing, jump and shoot. So you don't necessarily need it, but adding it makes it very easy to read. Alright, so that's enum flags. It's a great way to store multiple enum values in a single enum field. This is really excellent whenever you want to store combinations of values instead of storing just a single one.